This is Jake Bazicki with an ACT Science data interpretation question. Now, this question is asking us about the adjustments to temperature and to pressure that would result in a phase change in the material that we're talking about from a gas to a liquid starting at point D. Now, to understand this question, you really need to understand what's going on in this problem, in this passage, with both the diagram and with the text and the tables. So if you weren't, this is one of those times where if you aren't sure what's going on when you read this question, make sure that you read the passage to figure it out, because anytime that they give you something that is hard to understand, they will explain it in the passage. So here we can see that we're talking about a change of phase. So when a material goes from a solid to a liquid or to a gas or anywhere in between there, and how the limits of temperature and pressure will result in a change from one phase to another very drastically depending on the material. Okay, and so we talk about these limits with phase diagrams. And the lines in a phase diagram are where they represent the temperatures and pressures at which a material is changing from one phase to another. So at a given temperature and pressure on either side of the line, the material exists in a different phase. Those temperatures and pressures on the line, the material exists in both phases simultaneously. So this is a phase diagram. And if based on what you just read up top here, you can see that on one side of this line, we're going to have a material that's one phase, and on another side of this line, we're going to have a material that's a different phase. And so if you look, for example, we see point D, which is the point we're being asked about here. We see that at point D, that this material that we're looking at is a gas. It's in a gaseous phase. And we can see that at point C, that it's a liquid. So anywhere in here, anywhere in this area is a liquid. Anywhere in this area on this side, the right side of the line, is a gas. And anywhere in these areas where points A and point B are going to be solids. And we can see that from the table 1 here, where point A and B are solids. So the solids, liquids, gases. So we're being asked what change in temperature and pressure would result in a phase change in this material from a gas to a liquid. So we're trying to take this material from point D, from a gas to a liquid. And so what changes in pressure and temperature would do that? So let's go through our different answers, because this is one of those problems that's very confusing and you could easily make a mistake if you're not careful going through each answer choice. So let's start with the beginning. At a constant pressure, decrease the temperature. So this axis we can see is temperature increasing this way, and pressure is increasing this way on the y-axis here. So at a constant pressure, so with pressure remaining exactly the same, so we'd be saying at this pressure, we would decrease the temperature. So our temperature would actually drop. So answer choice A is basically saying that keeping the temperature the same, we drop this way. And we actually see that eventually, if we drop the temperature, we would get to point B, which is a solid, so not a liquid. So we can actually cross that out because that's not the right answer, because eventually this would eventually just pull us over to a solid phase, which is not what we're looking for. We can cross that out here. Next, the answer choice B, equally increase the pressure and temperature. So if we increase the temperature and pressure in an equal amount, it would increase like this, upwards and to the right. Because as we go up 100 Kelvin, we go up 100 atmospheres, pressure per atmosphere, pascals per atmosphere. And so we'd increase the pressure, and we would sort of be, we would just be sort of making this trend to the up and to the right, which would keep us in this gaseous area, keep us in this gaseous phase, would not be transferring us over to a liquid. So we know that's not what we're looking for. Decrease the pressure while decreasing the temperature, which would be exactly the opposite, pulling us this way on the chart, which is not what we're looking for. And then the last option, increase the pressure at a constant temperature. So we're going to stay right at this temperature, right here, but we're going to increase the pressure. And so we would be taking this straight up on this diagram, and voila! We're in this phase, this area here, trapped in between these lines. That is the liquid phase, and that is our right answer.